Okay, good afternoon. Thank you for the invitation. It's an honor to be here. And in these beautiful facilities, I think they're very nice. I'm going to speak of automatic um, video analysis and intelligent cities. Well, ProBayes, for those of you who are not familiar with this company, who I assume will be most of you, because we're a relatively small company. It's a company born in France. We have offices in Grenoble, in Paris, and we have um, uh, an office here in Puebla. ProBayes not only works with video analysis, we do big data services in general, and we started working for Toyota in management aid. We help with banks analyze millions of transactions per day. We work for the army. We have a few interesting games as well. The variety of applications is stunning. So in this case, we will speak of video analysis and intelligent cities. So intelligent cities, or the idea of intelligent cities, is born as a concern with regards to the fact that there will be more and more people in cities every day. Currently, we have about 50% of the world population living in cities. And suddenly, well, in 2050, we expect that number to rise to 70%. And this will lead to an increase in population as well. It's like one day at our home, they said, "Oh, your cousins are going to visit, so okay, you have to pull the mattress out of the room, etc." So we need to do something intelligent so we're able to coexist. And so that each of the decisions made lead to us working better. So it's a whole series of, well, one of the most recurring ideas is that we'll have an ubiquitous city where with sensors everywhere on roads, on parking lots, in trash bins once they're empty, so we can optimize. But it's not only this. It's not about technology. There are other actions which we've began taking. For instance, bike share programs, they don't require that much technology really. It's just the technology which allows me to return the bicycle, or parking meters which you pay with your phone. You no longer need to find coins, and when I return, I've been, given a fine because I went to look for some change. So it's about the state of the city so that I may make better decisions. This in combination with elements such as smartphones, which are going to allow me access to this information immediately. Um, this we need to work on what we already have. For instance, this is a photograph of Puebla where Provalles is, and it says Puebla straight, San Andres Cholula to the right, San Pedro Cholula to the right, and actually it's this point on the road. And if you want to go to San Andres Cholula, you have to take the exit, take a part of the road, and then um, return. So this sign is not intelligent. It's not the sign of an intelligent city, because you have 1, 2, 3, 4, 5, 6 intersections. Okay, we'll say 5 intersections right before me having to turn to the right. So when we speak of intelligent cities, we need to think that we need to improve the signage that, well, in Mexico hasn't really progressed since the 70s. So What actions are we going to take? There's going to be different actions. Of course, technology is one of them, but there are going to be mechanisms related to price, quality of services, access to services. This picture shows what it was like when there were no parking meters in London City, when they put them, and when they raised the price of parking meters fourfold. So no one wants to drive anymore when that happens. So we're going to refer to video analysis. Videos are everywhere. We have them on our phones, on our surveillance cameras. We carry them with us as part um, of our apparel. For instance, like the GoPro cameras, etc. So we want to provide tools that will help better decision making, or to analyze, or also to analyze all this information which is impossible to analyze rapidly. Intelligence, as an intelligent city, requires perception, and depending on the time of the day, you can say that it's one color or another. There's some uncertainty. So the tools we use are uh, Valesian Valesian networks. That's where the name of the company comes from. So we use the Valles theory, or if I'm going to throw a dice, um, you will tell me how many I have. So I have a uniform a priori, and when you say, okay, 10 points, I'm going to change the distribution of probabilities, and if they ask me um, how many numbers I'm going to get without changing the number of dice, we're going to know with some certainty what number what numbers um, have been played. So we have several images, and each image we want it to give us information. So we have an inferral motor, but it infers approximately, and it allows us to program model. What's most important for us in video analyses is the Bayesian occupancy filter, which is when we detect an object with a sensor or a camera, which can be laser or others, we will know its position, but we will also, let's say, in the z-axis, the probability of the speed. So if I say a speed is 0.8 and -1, the object we have here, well, we'll have space, which we are surveying, which will be the occupied space. Also, the free space, where we know there will be nothing. Also, the non-observable space, which is beyond what the sensor can register, and the space covered with or by an object. So when I combine several sensors, I can, well, do the check the layers. If I take the 0 here, for instance, I wouldn't see the object in purple because it's not working at the speed. Let's say it's a cake. The layer, well, with a fan shape, 0, we would not see it, but if we go to 008 layer, then the object would be seen. So we create a model with this Bayesian filter, which allows me to combine several sensors. So we are going to merge information, and this is going to allow me to follow each of the objects, even if the objects are moving in a different direction, or if there's some time of barrier, which hides them for a moment. So even with this principle in mind, we can say we have a system that allows us to follow up or to follow objects. And with this in mind, so we can follow statistics on where my team was for the longest, why we failed, etc. Um, we might we can do other applications, but we can say that we can do the system for video analysis in a train station, and we can detect intruders where they are not desirable. And through this system, we can learn the shape of objects to determine if it's worth. And well, this was one of our first application, and it was vehicle counting. If you have people counting, they don't count as well as a machine. If it's tomorrow, it's another person, they won't count as well either. So just when Mexico was playing, we realized that the traffic in front of our offices dropped 20%. So this information is very valuable because I can tell how a city is behaving. I'd even like to know what type of vehicles are are circulating. So we have these types of systems for auditing in the um, in the well the collection uh, areas. Sometimes the government builds it, and someone else manages the tolls, so the government can't expect access to the system. But through this camera, you can count the number of vehicles that pass and even detect if there's any intruders. So as I said, this is the task. This is the most simple task we can imagine, and there are other which are a bit more complicated. Even though those who are very good at observations are not going to do this. So imagine you have to pass 3 hours watching the screens in case something strange happens. So if an experiment, well, many of you are probably familiar with this. I'm going to ask you count the number of passes of the white team. Count them. Are you ready? Count the number of passes, of completed passes. Of the white team. $15, $14. Okay. Well, we could discuss this, but I'm going to ask you another question. The gorilla. The gorilla. Who saw the gorilla? So there's a percentage of those who I've trusted with security who did not see what was happening on the scene. The objective is to try and extract the most we can from the videos. It's not an easy task when we know that our system of perception may be tricky. We concentrate on one thing and we avoid detecting others. So what we're trying to do here is to have a system that analyzes video, and when I'm interested in exploring certain characteristics of it, I can do so easily. If you said to me, find the trash, the trash car or truck, the trash collection one, well, you would have to watch it for 24 hours. So you decide to increase the speed, you watch the video, and maybe you never see the garbage disposal truck pass. So how are you going to do this? You're going to do it in the following way: through the video analysis system that has the capability of tracking or following up on each of the elements. You choose a camera, you say detect the videos that passed at a certain time, and you're going to see what happened in isolation, not everything that passed. You will now be able to see it without there being any movement. So we can see the level of activity, what vehicles passed at this at a certain time. So I start navigating, and when I find the vehicle I'm interested in, I'm going to be able to find one or several pictures, and then I can go to the video segments. This is a corresponding video segment to show at what moment it was passing. On the photograph, you have the exact time at which it drove by. So this will allow me to reduce, obviously, my times, the time I spend looking for a vehicle. So we have other applications inspired on this in this industry. We have cars that distribute parts to workers. So we place cameras, and and when this car passes in front of the camera, they register it, and we can have a series of graphs, times, and points, and we can detect whether this car did its followed the route it should have followed. So we'll have the following data. The one on top is for one vehicle, the one below is for several, as well as a series of statistics. For instance, average time. We can do the same with faces. You place a camera somewhere, and each of the faces is registered, and the photograph which is considered the best of an individual will be stored with the rest, and I will keep it so I can navigate rapidly. If I'm a watchman, or with my tablet, I can see who's entered in the past 20 minutes because I had to go to the bathroom, and somebody can say, oh, I don't know who this person is. So when this person uh, comes along, it takes a picture, and then it chooses the picture it considers most representative. So thanks to the system, to put this simply, what it does is detect the entity, and we have another phase in which we extract whatever is of interest for us. For instance, faces. I can do this for vehicles, or I can do it in a factory for a part I'm interested in. I call it future extractor, and I can store it, I can use it to extract vehicles and to create statistics on the number of vehicles uh, that that are currently driving down a certain avenue. And this, of course, is important because I can create statistics on the density of a certain avenue. It's changed. For instance, we close a certain avenue because we're going to place hydraulic cement. So where is traffic driving down now? But what traffic is leaving, so I can realize if it's trucks, if it's cars, if it's SUVs. So we had a study for a bus company that was interested in knowing what market segment they had between um, Puebla and Mexico City. And it was not easy to know, but if you can compare the type of traffic we have with regards to last year, I can tell you if if you're moving forward or not. And so we can classify vehicles. And here is another example of how this type of tool um, makes our work easier because we're we're able to select the camera. We're able to select the date at which I would like to conduct the search on. So I just pull the or drag the camera to the query box, and it detects three types of entities. I want to detect vehicles. I want to detect all the vehicles that are red, and then I provide a probability. How strict do I want to be with the color red? Maybe some of us call it red, others call it orange. So let's play a bit with this. Let's say 0 0.4. So we send out a query and we receive all the cars that the system considers red, and I can begin navigating to see if I find the object of my interest. So if you want to buy a car in a month, ask me what the most common color is, so you don't buy that one. Anyway, when you buy a car, the next day you have the impression that everyone has the same car, right? So you can do these types of queries. You can do the same with license plates. You extract the license plate and the same interface. You can move from left to right with what's been captured. License plates. You can analyze what's happening. This is in front of our offices at Puebla. So first, it would be hard to say something about the scene when we analyze, when we statistically analyze the space. We can say that there are areas that are more used than others, and this can be of use to plan a better city. If we superimpose images, we can tell that there's a use of the middle lane, which is more frequent than the right or the left one. And we have another stain here, which responds to the exit to the tech park. And the one in the center, well, it's reasonable because you can choose to take the left or go straight or go to or to enter a high school, which is a few meters down the road. So that would help us identify some type of conflict. And of course, the dream of us all is to detect behaviors. Behaviors through a Bayesian model is not too difficult as long as they are relatively simple behaviors. When these behaviors are more complex, then of course it's more difficult to do so. So we're able to capture for a specific environment where we place the camera, we learn how entities behave in this environment, and if something strange happens, we can sound an alarm.
However, that is not exportable. That means that what I learned there is not something that I can take and apply generally and then placing a camera wherever I want to say, well, there's something weird happening. So what we did is a system such as this to find out if a situation is normal or abnormal. There are some cases in which this goes up because somebody walked faster than the normal speed, touched parts that were not usually transited, and so on. And to finish this, there's some other things, somewhat fun that we can do when we try to know the behavior of an individual. In this case, we wrote a dialogue box, and people raise their hands. We, for example, put a globe saying, well, "Hello, mom. This is Juanito." Things like that. And we do that sort of thing for advertising in shopping malls. When you go inside the shopping mall, there's a mirror. You see yourself with a bubble saying, well, bring me a six-pack of beer because the today is the Mexico's game, and that is not part of intelligent cities. But this is interesting in terms of everything that is being done for video analysis, because video analysis can be applied for a lot of things, especially to better manage the city and on energy matters, for example. For energy purposes, this will be very, very useful because usually the red line is what would be spent as energy, and if we were to consider what is happening in the city, then that would be represented by the green line here. And we're also working with Toyota and on smart vehicles. In this case, this is a camera mounted on the top of the vehicle. The green colored area is the field of view of the driver, and red is everything the driver is not seeing. So if a vehicle enters the red area, then the seat will vibrate. Well, we know that when somebody has a certain level of experience while driving, and we let our children drive, for example, we're somewhat worried, and we do not know why we're saying it, but we tell them, well, this guy's about to change lanes without signaling, and this is a system that will do precisely that. It will be monitoring the vehicles going in front of us to anticipate the most likely maneuver they will carry out. If the left bar indicates that they will turn left, and this is part of what smart cities will be. It is not only about placing sensors around the city's infrastructure, but also in all those elements that intervene. This is this is part of our architecture. However, I do not have more time to explain it. For those of you that are interested on this topic, our book has just been published. It's Bayesian programming. It is available on Amazon, and it has a lot of examples, such as this one. A lot of practical examples regarding the use of Bayesian theory for several applications. So I thank you very much.